Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class. Today we are going to be looking at Newton's law of motion for part 2. By the end of this lesson, you should be able to define the first law of motion and its application, then second law of motion and its application, and the third law of motion and its application. Now, what we have to talk about today is the motion according to Newton's concept. So we are going to tap into the knowledge, the stream of knowledge of Newton, depending on what he said about motion. However, in this part of introduction, I want you to know that when we talk about motion, we are just talking about a body moving from one point to the other on a plane. It may not only be on a straight line. There are different ways of having motion. It can be oscillatory, it can be vibratory, it can be rotational. Any kind of motion is what Newton stated, and we are going to look at them. If you have not really studied the types of motion, a video has already been made on the types of motion. You can go and check it. Now, let's talk about the first law of motion, which is mostly called the law of inertia, according to Newton's law. And Newton stated that everybody will continue to be on each state of rest until it's acted upon by an external force. That means a body can continue on each state of rest forever. You keep a phone on your table, it will remain there forever until something else comes, a force, and moves it away from that position. However, another form of this law also states that probably a body will continue on each state of motion, on a uniform motion, until it's acted upon by an external force. So, even when a body starts moving, it continues moving forever until an external force makes it to come to stop. So, there is something we call the inertia, which is the massiveness of a body, or we talk about the reluctance of a body to do something different when it has continued on a particular case. For example, when somebody is running, for example, when you watch a race like 100-meter race, you notice that the person will continue moving. And when they say stop, you can't stop immediately. Even a moving car, you can't say, I have gotten to the place I'm going to and I want to stop. You match brake at that point. The car can never stop. Why? Because as the body is on that motion, the whole thing about the body will want to continue on that motion. So when you want to stop it, there is this reluctance on the body to stop. And that is what led to so many applications. Even the chair I'm sitting, you see this? This thing here is as a result of jerking. And that is why you see them on cars. If a car is moving and instantaneously a brake is applied, you see people jerk back. So they put that to avoid breaking of neck and some other things. So what we are talking about here, Newton's first law, see, this is not based on practicals. They are not based on experiment. It is based on physical observation. So he said that everybody will continue to be on each state of rest or of uniform motion, except acted upon by an external force. So that is what Newton said. And we talk about the inertia, which is the first law of motion, is called the law of inertia, which talks about the massiveness or the reluctance for a body. Now, there are a few applications of first law. For example, the motion of a satellite or the motion in its orbit continues going in that direction forever, and it has been there forever as far as the earth has remained. That motion, or the motion of the satellite or the moon, remember the moon and the satellite, they are almost the same thing. It's all about natural and artificial. So they continue on that state of constant motion, constantly moving, and nothing has stopped. And if something makes this to stop, then there is a problem. The number 2, which I have just told you, is the jerking when brake is applied. So whenever you're moving on with your car and suddenly a brake is applied immediately, there is a jerking. So, and that is why the wise people came up with this to avoid harm. Another one is a cyclist riding along a level road. Does not come to rest immediately brake is applied. You can also try it. Start running and they say stop. See if you can stop at that point. It's not possible. You will feel this reluctance. You don't want to stop because you're already moving until you now take it gradually. That is why car, when brake is applied, car comes one brake, you do another one until it comes to rest. These are all natural happenings which Newton, Sir Isaac Newton, came up with, and he called it the first law of motion. The second law of motion, which is very, very good one. I love this motion. It says that it said the rate of change of momentum is directly proportional to the force applied and takes the place in the direction of the applied force. And that led to, you remember we've done a lesson, we've had a lesson on momentum. So when we talk about momentum, we talk about change in momentum, where we say that Ft, this F2 is talking about the impulse. The impulse, then we said that this impulse is the same thing as change in momentum. When we talk about change in momentum, we are talking about momentum before and momentum, final momentum minus initial momentum. Initial momentum means the mass of the body multiplied by initial velocity, while final momentum is the momentum mass of the body multiplied by the final velocity. So which we say that F is equal to mv minus u all over t, which gave birth to this formula, which is the force, the formula of the famous formula of force, or general formula for force. And that is what Newton's law stated. And I'm going to tell you just the secret behind all the problems you keep seeing, IGCSE, WEAC, JAMB, JUPEB, all those exam questions. I know so many people don't understand, but in this class we are going to look at them. But however, this is, remember, this is just a state of fact, it's an equation. But when we talk about the law, he stated it like this. He said that the force applied on a body is directly proportional to the change in momentum, which is this v minus u all over t. So this is what it is. You know, remember, according to the variation you learned, if I remove this proportionality, I'm going to introduce a constant k m v minus u all over t, where we said by assumption that this k is 1, and that gave birth to this formula. If you say that k is 1, you have this formula which led to this force. And that is what Newton's law stated. Now, let me just go straight to talk about all the things that Newton's law is all about. Then we do a few of the calculations on Newton's law. Now, let me state it the way you see it in your textbooks. Let me show you the way you see it in your textbook. However, before I go to this, I want to let you know something. They say that there are different kinds of equilibrium. Remember, we also had a lesson on equilibrium. We had equilibrium of a body in terms of its stability. And I mentioned that a body has to be in equilibrium. There are so many bodies that has to be in equilibrium. For example, the building you are staying in has to be in equilibrium. If it is not, then there is a problem. However, we have two different kinds of equilibrium in terms of the forces acting on them. We say a body can be in static equilibrium. When a body is in static equilibrium, it means that the total force acting on the body is 0. That means if this is a body, the force acting upward, maybe normal reaction, and the weight of the body must be at 0. Remember, if I pull this ball upward, and then it continues moving upward, it means that it's no longer in equilibrium. So for this body to be in equilibrium, it means that the sum of all the forces on y direction must be equal to 0. That means there is not going to be a net force. That means there is no a net force. When we are talking about a net force, we are saying that the body is not accelerating. The body is not accelerating. So that means the force acting on upward force and the downward force, they must be equal to 0. Simply put, this is the way it is in the textbook. Or however, if the body is moving upward, it means that R minus W is equal to 0. However, if I also remove this, we said that the force applied, probably the frictional force, if the body is moving in this direction with an acceleration, then we say that the body is no longer in equilibrium. I mean in terms of static, because we also have dynamic equilibrium. But then if we say Fp minus Ff is equal to 0, that means that acceleration is 0. So in that case, this is the static equilibrium. However, that is according to Newton's first law of motion, which says that the body must be in equilibrium. That means at rest or in its uniform motion, such that the velocity is going to be constant. Because if velocity is constant, that means the body is not accelerating. However, in this second law, something different happens. It happens because the body must be moving. That means the body must have been moving. And that is why he stated here, he said, and to the force, he said that the change in momentum is directly proportional to the force and takes place in the direction of the force. That means there is a movement. And that movement is in such a way that this is not going to be equal to 0 because there is going to be a net force. And that net force is change. Whenever you have change in mathematics, you know that there is a net. There is a net force. That means the force in this direction minus the force in this direction is equal to the mass times acceleration. And this is the essence of this Newton's second law. And it has massive application and so many areas, especially when it comes to exams. Also, according to this second law of motion, or which we call dynamic equilibrium. No, not dynamic equilibrium. I mean, according to this second law of motion, we say that the sum of forces in the y direction is not going to be 0 in this case. According to Newton's second law, it's going to be equal to ma. That means the body is accelerating. Now we are going to solve one calculation to back our theory up. Now look at the example. It said a mass of 6 kg is dragged along a rough surface of frictional force 2.5 Newton, opposing the motion by a horizontal force of 30 Newton. What is acceleration produced? Okay. I'm going to still keep this body here as the analysis for this question continues. A body of mass, this is the body and this is the mass, 6 kg, and is dragged along a rough surface of frictional force. So now let's assume that this is the surface. This is the surface, and this surface has a frictional force. That means force that is opposing the motion, and that force is 2.5 Newton. And opposing the motion of a horizontal force, that means the force moving is 30 Newton, moving in this direction. Now, a human being with a common sense should know that if this place is 30 Newton, it's a bigger force, and this is 2.5 Newton, it's a resistance force opposing it. It means that the opposition is not enough to stop this motion. And that means the body is going to be moving in this direction. So we are going to call it maybe Fx. Why am I using Fx? I am just saying that the body is moving on an x-axis, in the positive x-axis. Why this one is moving in the negative x-axis? Maybe if I call this one Fx1, maybe I call this one Fx2. Anything I like to call it is my choice. Now, according to the law of vectors, which we have learned, we say that when vectors act in opposite direction, what happens? They subtract each other. And according to the second law of motion, of Newton's second law of motion, he says that whenever there is a movement, then that means there is a net force in that direction. However, I'm going to say that Fx1 is moving in this direction minus Fx2 is going to have a net force which is equal to the mass times the acceleration. That is the essence of this law. Fx1 is 30 Newton minus Fx2 is 2.5 is equal to mass is 6 times I am looking for the acceleration. So 30.0, 2.5, this is 5, 29 minus 2, that is 28. 27. So this is 27.5. So we have 27.5 is equal to 6 multiplied by acceleration. So acceleration is going to be 27.5 divided by 6. Then acceleration, that means the acceleration with which the body is using to move in that direction. So if you have 27.5 divided by 6, we have 4.6 meters per second square. You need to put the unit of the acceleration. So that is the acceleration produced as the body is moving in that direction, according to Newton's second law of motion. We also have a second question, and this one came differently. A box of mass 4 kg rests on a rough horizontal table. So this is a box, and this represents the table, right? That the mass of the box is 4 kg, rests on a rough table. A force of 25 Newton is applied to the mass at an angle 60 degrees to the table. That means then a force is applied. Let's assume that this is the horizontal level of the table, of course. Then at this point, a force of 25 Newton is applied to an angle 60 degrees. I don't know if you have experienced that before. At least you see people tying rope on a load and start pulling it at an angle. Now, a box of mass 4 kg and rested on a rough table, and the force of 25 Newton is applied at an angle 60 degrees to the horizontal, and then a frictional force of 8 Newton is acting. So frictional force must move in opposite direction to the direction of the force. I say, what is acceleration? So the body is in motion. That is the essence of Newton's law. As the body is in motion, what do we now do? Remember when we learned about resolution of forces, we said that at an angle you have to resolve it vertically and horizontally, but at this point we don't have any business with the vertical because the body is not moving on the vertical axis. The body is moving on the horizontal axis. So I'm going to find the most effective horizontal force that will take this body moving on the horizontal, and that is going to be resolving this 25 Newton on the positive x-axis. Remember, positive x-axis, negative x-axis, it doesn't concern us because see, there is no rule in mathematics that says that positive x-axis must be in the right direction. It's just people who are just using it. So there is no law. So I'm going to choose, even if I choose here to be my negative, I'm going to choose this place to be my positive. That is just it. However, to maintain the status quo in physics, let's continue using this place as positive x. So what am I going to do? I am going to resolve this projection of this vector on the horizontal axis. So I'm going to have, so this is going to be fx. And that fx is going to be adjacent over hypotenuse, and that is cosine. So I'm going to have that fx is equal to 25 cos 60. That is the force that this body is using to move on the horizontal. So I'm going to redraw this whole thing in another diagram called free body diagram. So that is going to be like this now. See the way it's going to be? It's going to be 25 cos 60 all Newton, and this is 8 Newton, and this is 4 kg. So this is what is happening here at the second stage, because the whole force of this has been resolved in this direction. So what am I going to do? According to Newton's law, or second law of motion, who states that the sum of the forces on that x direction is equal to ma, which is the net force is equal to na. So what is the net? Net means minus. And since it's moving in this direction, I'm going to say 25 cos 60 minus 8 is equal to ma. I'm looking for acceleration. So what is the m? M is what? 4. That is the mass of the body. So let's find cos 60. Cos 60 0. Okay, let's say 0. Cos 60 0.5. Cool. So we have 25 times 0.5 minus 8 equal to 4a. 25 times 0.5 is going to be 12.5 minus 8. So this is going to be, so this is 12.5 minus 8 equal to 4a. So 12.5 minus 8 is 4.5 equal to 4a. So the acceleration at that point, so the acceleration here is going to be a is equal to 4.5 divided by 4. So acceleration is 1.125 meters per second square. So that is acceleration on this question. Now let's talk about Newton's third law of motion. It says that any action is equal and opposite. Or you can say that for every action, there is equal and opposite reaction. So this law is the most effective law I've ever seen in real life, physics, anything you do. Whenever you take an action, there must be equal and opposite reaction. When you talk to somebody, there must be a reaction. When you hit your head on the wall, you will feel the pain. But normally, it was supposed that you are the one applying the force. You are not supposed to feel the pain. However, once you hit your head there, there will be a reaction from the wall on you. If you are standing, why is it that when you stand for a long time, you feel pains? You want to sit down, you want to rest. Why? Because as you are there, standing, your weight, gravitational force is acting on you, while the ground is also acting on you. That is why your legs start paining you. For every action, there is equal and opposite reaction. And that is the famous law, third law, according to this level of physics by Sir Isaac Newton. There are a few applications of this law. It says that in explosion, explosion is a special case of collision in which momentum is conserved. What do we mean by saying that momentum is conserved? We say that whenever you hear conservation, because there was a time this became a very special issue and problem. When we talk about conserved, we are saying that there is no change recorded. That means the thing that happened before is the same thing that happened after. That is the meaning of saying conserved. That means whenever there is an explosion, there is no change in momentum. Nothing has changed. Nothing changed. But potential energy is converted to kinetic energy. And remember that they say that energy is neither created nor destroyed, but is converted from one form to the other. It's an example of this kind of case is firing of a bullet from a gun. When a bullet is fired from a gun, it jerks backward. That is why when you shoot a gun, you feel a force in your own direction, or we call it recoil. However, the initial momentum of the gun is 0. Let me show you what I'm talking about. Now, I'm going to start this explanation with what we learned in momentum in terms of collision. Remember we said that M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. All right, this is the general formula of momentum. But you can never use this formula without a full understanding of what is happening to this V, which is a vector, and this vector, U and U. Their direction matters a lot, which has been discussed in another class on momentum. Now, but look at what it says. It says, however, initial momentum of the gun is 0. What is the initial? Everything that happens here, from here to this place, is the initial momentum. Or we say initial momentum. Sometimes we also say momentum before. I like to say momentum before. Momentum before collision. Before collision. All right? So everything about, listen, this is only applicable to recoiling of a gun or the explosion. So whenever you have a question on explosion or recoiling of a gun, what I'm explaining is what you are going to use to apply. Now look at what it says. Therefore, we are going to have 0 is equal to M1 V1 plus M2 V2. Is this enough? Not yet. It's not enough. He said, when the gun is fired, when you fire a gun, that is collision has occurred, then the gun, the bullet is going to move forward. When the bullet moves forward, what happens to the gun? The gun moves backward. So V1 is the velocity of the bullet, and V2 is the velocity of the gun, which is going to hit back. So whenever there is a movement in the opposite direction, that V2 is no longer going to be just positive. It's going to be minus V2 in this case. So the whole formula turns to be 0 is equal to M1 V1 minus M2 V2. So when you carry this over to the other side of the equation, you have M2 V2 is equal to M1 V1. This is what led to the formula you always see in this recoiling of a gun, and which is what was stated here. The application is in this one, which I've already explained. Momentum before equal to momentum after. So momentum before is 0, and momentum after is according to the explanation given here. Okay, let's look at this question. A gun of mass 100 kilograms fires a bullet of mass 10 grams at a speed of 40 meters per second, sorry. With a speed, with what speed does the gun recoil? So we are going to apply the third law of Newton's third law of motion, which says that that the mass of the bullet, okay, like we are saying, let me use this one. So we are saying that the mass of the bullet and the velocity of the bullet minus the mass of the gun and velocity of the gun. So that means this one is equal to the, any one of you are choosing, they are just equal to each other. So the mass of the bullet and velocity of the bullet is going to be equal to the mass of the gun and velocity of the gun. That is just it. And so we are saying that a mass of 100 kg fires a bullet of 10 grams. So the mass of bullet is 10 grams. So I'm going to use the mass of bullet is here, 10 over 1,000. Why the 1,000? I want to convert grams to kilogram and multiply by the velocity. So with what speed does the gun recoil? So we already know this one as 40. And this is going to be equal to, the mass of the gun is 100 kilogram multiplied by the velocity. So we are looking at the velocity, we are looking for the velocity of the recoil of the gun. So this we cancel this, this we cancel this, we have 0.4 is equal to 100 times VG. So VG is equal to 0.4 divided by 100. So this is VG is going to be equal to 0.004. because this is going to move 1, 4. So this is going to be meter per second. So the speed of the gun, which it used to recoil, is 0.04 meters per second. Thank you. We have come to the end of this lesson, but remember, before we go, we have to take a few exercises from Examguide app. So let's go to it. Okay, so we are in the Examguide app. This is my UTME JAMB app. So let's get started with those questions. All right, we have that a body accelerates uniformly from rest for a time t. The kinetic energy of the body at t is I, that is the first one, is directly proportional to displacement, is directly proportional to the square of the instantaneous velocity, is directly proportional to t square, depends on the value of the acceleration. Which of the above statements is or are correct? Okay, let's look at each of these options. Is kinetic energy directly proportional to displacement? Yes, of course, it's true. Because kinetic energy is given as half mv square. All right? Remember that v square came from this, u square plus 2as. When this is 0, especially according to the question, it said that it started from rest. So if u is 0, we said that v square is equal to 2as. Therefore, kinetic energy is equal to 1 over 2 m 2as. Remember, so kinetic energy is directly proportional to displacement, and that s represents the displacement. Is directly proportional to the square of the instantaneous velocity. Of course, if I change this, look at this here. Kinetic energy is directly proportional to this instantaneous velocity. Then the tray is directly proportional to t square. Yes, of course. If I remove this v and replace it with displacement over time, so I'm going to have 1 over 2 m s per t. In fact, I'm going to choose 1, 2, 3, 4. So option D is my best option. Now, a body of mass 4 kg rests on the smooth horizontal plane, is simultaneously acted upon by 2 perpendicular forces, 6 and 8 Newton. Calculate the acceleration of the motion. All right? I like this question also. So this one now is talking about perpendicular forces. The 2 perpendicular forces. If you can remember our lesson on resolution of forces, what do we say when a force is acted upon on a perpendicular angle between them? So this is an angle, 90 degrees, which is called the perpendicular angle. When they are acting upon this body of 4 kilograms, what is going to be the resultant? Because what we need now is a resultant force. That is the net force on the body. And the net force on this body is going to be application of the Pythagoras expression. And then since the force is 8 and 6, so we are saying that the resultant force is going to be equal to square root of 8 square plus 6 square, which is 64 plus 36, and which is square root of 100, which is 10 Newton. So 10 Newton is the force acting on the body. However, this force is going to be equal to MA because this is the net force. And this is going to be 10 is equal to M is 4 times acceleration. And acceleration is going to be 10 over 4, which is 5 over 2, and which is 2.5 meters per second square. So the option B is there. Let's look for at least a theoretical question. Oh, time for handling this. Okay, this one. A force of 100 Newton is used to kick a ball of mass. Find the velocity with which the ball moves if it takes 0.8 seconds to be kicked. All right? Football. So this question is directly application of F is equal to M V minus U all over T. Yes, that is the formula. A force of 100 Newton is equal to, it's used to kick a ball. A ball was at rest before the kick. So I'm going to have, the mass is 0.8 times V is what? Okay, find the velocity. So I'm going to use V minus 0 because 0 is that the body was at rest. Divide by 0.8 because 0.8 is the time. This will cancel this. We said that V is 100 meters per second. That is a very high speed, and that is option B. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.